Hello, this is Mr. Collier, and today we're doing this rates question with a couple of astronauts. Okay, so Pat and Mike are orbiting the Earth in separate space capsules. They were orbiting in the same direction, on the same plane. Pat orbits in 3 hours, Mike in 7.5, so Pat's going faster. At 12 noon, Mike sees Pat directly below. The new time that Mike's capsule is directly above Pat's capsule is one of these options. So let's draw a picture first. So here's the Earth, and it says Mike sees Pat directly below. So Pat is in a lower orbit. Let's call that P for Pat. And he's going around in the same direction, in the same plane. Let's assume that's a perfect circle. And Mike's a little bit further out, and he's going in the same direction. Okay, so at 12 o'clock, noon, they're directly above each other. And because Pat's going faster, he's going to make one complete revolution and still not meet up with Mike again. Mike's going to be gone just a little bit further because he's a lot slower, or maybe it's more like half or something. Okay, so this is the situation after one revolution. So first, let's take a look at their rates. Now, they're not exactly going the same distance around because Mike's in a further orbit, but you can think of the angle that they're going as their distance, right? So after 3 hours, Pat's gone 360 degrees, and Mike's gone a lot less. So we can figure out when they'll meet again. At what angle will they meet again? So maybe Pat and Mike will meet again here, or actually I think it's going to be a little bit further, but it's going to be sometime before 6 hours. Okay, so let's look at what happens after the 3 hours. And actually, let's look at the rates first. The rates of Pat and Mike. So for Pat, his rate is per hour. So he does one revolution in 3 hours. That's 360 degrees in 3 hours. That's 120 degrees per hour. Now for Mike, we've got 360 divided by 7.5. That's actually 48 degrees per hour. So after 3 hours, Pat's gone 360 degrees, and Mike has gone 3 times 48, which is 144. So next, let's look at what happens here. Let's first of all remind ourselves that distance equals speed times time. Now the distance Pat travels from that point to the meeting point is going to be speed times time. So let's call it 120 times whatever that time is. That's going to be equal to this distance here traveled by Mike, okay, which is speed times time, 48 times the same time, plus this distance, which is 144 degrees, which we already calculated, right? So if you solve that, you get 72t equals 144. So t equals, if you divide by 72, you get 2. So that's 2 hours after the 5 hours, so the time they meet again is at 5 o'clock.